Today we're going to build a PC with Intel's new 12th gen Core desktop processors. And by the way, huge thanks to Intel for sending this over and sponsoring this video. And of course, all thoughts are entirely my own. So I'm going to go over the specs of Intel's new processors, then I'm going to go over the rest of the parts for this PC build. I'm not going to be doing a step-by-step guide with this particular video because I don't want to make this video too long. But then again, I say this in every single video, so I don't know. So I have two new Intel Core desktop processors, the Core i5, this is the Core i9. The Core i9-12900K and the Core i5-12600K. The 12th gen lineup features a performance hybrid design combining performance cores with efficient cores. So P cores or performance cores are essentially high-performing cores that are optimized for single or light-threaded tasks like gaming and some productivity apps. E cores or efficient cores are designed for multi-threaded workloads and also background tasks like if you had Discord open while you're gaming. 12th gen Intel Core desktop processors also feature compatibility with PCIe Gen 5, but I can't really test this out because I don't have a graphics card or an SSD capable of taking advantage of all this bandwidth. You also get DDR5 memory compatibility with a compatible motherboard, and I unfortunately cannot test that out either because this is a DDR4 motherboard. I also don't have any DDR5 memory, and as of filming this video, DDR5 memory is not really readily available anyway. I also wanted to point out that Intel's new 12th gen processors are compatible with DDR5 and DDR4, but if you have a DDR4 motherboard, don't expect to be able to put DDR5 memory in this thing, and if you have a DDR5 compatible motherboard, DDR4 memory will also not fit. Essentially, DDR5 is not backwards compatible. But these features do future-proof your PC build for years to come, and I'm really glad to see that Intel is finally at the forefront of all this new technology. And the Core i9-12900K has 8 P cores, 8 E cores, and hyper-threading on the P cores for a total thread count of 24. You also get a base clock of 3.2 GHz and a max turbo frequency of 5.2 GHz on a single P core and 125 watts of base power draw, but we all know that's going to be different when you start gaming or benchmarking the system. The Core i5-12600K has 6 P cores and 4 E cores with a total thread count of 16, base clock of 3.7 GHz and a max turbo frequency of 4.9 GHz on a single P core. I'm not going to overclock either of these processors because Intel Turbo Boost 3.0 should be more than fine for the everyday usage, should provide a slight automatic boost in performance as long as you have the thermal headroom and the power headroom, which is to say as long as these processors are running cool enough and you have a beefy enough power supply to power everything. And a little bit more about thermals, Intel's using thinner dies and slightly thinner soldered thermal interface material with thicker heat spreaders, and that should provide slightly cooler temperatures, but obviously we'll have to test that out in this video. And now that I've gone through most of the specs when it comes to Intel's new 12th gen Core desktop processors, let's talk about all the other stuff that's in this PC build. So for the power supply, I'm going with an 850 watt 80 plus gold unit from MSI, as well as a case from MSI. I just had these two parts laying around and I figured I might as well stay consistent with this build. A 360mm AIO liquid cooler. This is the Z690 Tomahawk with Wi-Fi. It's a DDR4 motherboard, so it's only compatible with DDR4 memory. And yet again, if you want to use DDR5 memory with Intel's new 12th gen processors, make sure to get a DDR5 compatible motherboard. Otherwise, don't expect to put DDR5 memory in this thing. For the graphics card, I'm going with a 3080 Ti. This is just the one that I pulled from my main PC. For storage, we're going with a 1TB PCIe 4.0 SSD from Sabrent. And why am I holding a 980 Pro box? Well, I bought the 980 Pro on Cyber Monday and I put that in my main PC. Yeah, we're sticking with the Sabrent one. For RAM, I have 16 GB of 3200 MHz Corsair Vengeance RGB Pro, cast latency of 16, not the fastest memory kit out there, and it's not like a 32 GB or 64 GB kit, but we don't really need anything fancy because 16 GB should be fine for most gaming situations and also video editing as well. As long as I don't do anything super crazy with like visual effects. That was not intentional. I accidentally clicked the power switch on my power strip for the table, but that was kind of cool. And by the way, all the parts I use in this video are going to be linked in the description section below. Alright, so I guess let's get started on this PC build. So I tested out the Core i5-12600K first, and I hopped into a game of Overwatch, which is something I've been playing a lot of recently, and I'm absolute garbage in this game, so don't expect to see any amazing gameplay. I played at a resolution of 3440 by 1440 on my ultra-wide monitor with the epic graphics preset, and I got an average FPS count of 289. That's definitely a huge excess in frames that I don't even take advantage of because I'm actually using a 120Hz ultra-wide monitor right now, but that definitely allows for a lot of graphical headroom if I ever want to upgrade to a higher refresh rate monitor in the future. I also tested out the multi-core performance with the Core i5-12600K in Cinebench R23, and I performed 3 runs so I could average them at the end. The first score I got was 16,693, the second one was 16,578, and the third one was 16,653. The average came out to be 16,641, which is really impressive. I was looking at competing CPUs on the left hand side of the screen, and this thing scored fairly well compared to the competition. I tested out more real-world performance with video editing in DaVinci Resolve 17 Studio. I basically compiled 5 minutes worth of 4K 10-bit 422 footage from my Sony a7S III. I rendered the project with the native encoder and it finished in 3 minutes and 39 seconds, which is pretty fast, and I'll compare it to the Core i9-12900K in a little bit. For thermals, the max package temp I recorded with max RPM for all fans in the case, as well as max pump RPM for the AIO, was 62 degrees Celsius, and that was after heating the system with Cinebench R23 for 20 minutes. The ambient room temperature was 66.7 degrees Fahrenheit or 19.3 degrees Celsius. And obviously after doing all this testing, I had to switch over to the Core i9-12900K, so I unscrewed the cooler, wiped off the thermal paste with isopropyl alcohol, took out the Core i5-12600K and swapped it with the Core i9-12900K, and then put a fresh layer of thermal paste. I used Arctic MX5, put way more than necessary because I really wanted to make sure that every spot on the heat spreader was covered. I didn't want any hot spots on that thing. There have been many tests like the one from Gamers Nexus that have shown that thermal paste application really does not make that big of a difference, and I had a lot of Arctic MX5 laying around, so I figured I might as well use it. So when it comes to Overwatch on the Core i9-12900K at the same resolution with the same graphics preset, I got an average of 308 FPS. I didn't really expect much of a difference considering all the other components were kept the same. My 3 Cinebench R23 scores are as follows: 26,570 for the first one, 26,570 for the second run, which is the same score as the first, and then 26,636, tying it all together for an average of 26,592. And comparing this to other comparable CPUs, the score absolutely blew the competition out of the water. I was really shocked at this, but keep in mind this does come at a cost, and I'll explain in a little bit. I went back on DaVinci Resolve to render the same 5-minute project I did earlier, and with the native encoder, the project finished exporting in 2 minutes and 41 seconds. And while 1 minute doesn't seem like a significant difference, if we're exporting a maybe 30-minute to 1-hour video project, this would be a large difference, and that would definitely save you a lot of time. And moving on to thermals, the max package temp I recorded with max RPM for all fans as well as max pump RPM was 96 degrees Celsius, which is insanely hot. The ambient room temperature was 67.6 degrees Fahrenheit or 19.8 degrees Celsius. And just like before, I did a 20-minute run of Cinebench R23 to really heat up the loop to make sure that the liquid temperature wasn't skewing the results. And 96 degrees Celsius with the 360mm AIO liquid cooler is incredibly hot. I actually thought my results might have been weird, but I checked with other sources and they are pretty similar. So if you're planning on purchasing a Core i9-12900K, definitely get a large beefy air cooler or go with an AIO liquid cooler with a size of at least 360mm or bigger. You could also go with the custom water cooling route. That would be an excellent choice. I would like to say 96 degrees Celsius is incredibly hot, but that's running the CPU at 100% load, which most people aren't doing, and most people are definitely not doing this 24/7. So if you plan on overclocking this system or editing video projects very often, keep in mind temperatures will run hot. But if you're an average gamer, someone who maybe streams on the side, and you're not running your CPU at 100% utilization, this shouldn't really be that large of an issue. It's just that when you really start to stress test this processor, it starts to get really steamy. And to really tie it all together, daily usage for both processors was great. So I had Google Sheets open, I was basically just editing a graph, and I also had Spotify as well as Discord open in the background. I was listening to some music on Spotify as well as scrolling through some servers on Discord, and I experienced no hiccups. And going back to video editing, scrolling through the timeline was fairly smooth, but I did encounter an issue when I threw in all my 4K video files that I recorded for this entire video that you're currently watching watching, which is to say I had like 50 video files that were shot in 4K 10-bit 422 from the Sony a7S III. I was checking Task Manager and I was basically maxing out on all the RAM that I had installed, and the RAM was basically bottlenecking the system, so I installed 32 gigabytes of additional RAM. So I'm currently using 48 gigabytes while I'm editing this video, which is making the system run so much smoother. So if you plan on editing large 4K video files, definitely consider more than just 16 gigabytes of RAM. Otherwise, I really had a great experience with both of these processors. Yet again, thank you Intel for sending over these processors. I really enjoyed testing them out. I have a bunch more videos planned in the near future. This was basically just a quick and fun PC build and showing some quick performance metrics when it comes to daily usage, gaming, as well as thermals. Thank you all so much for watching. Please like and subscribe if you enjoyed the video.